Ladies and gentlemen, welcome to the Business Brew. I'm your host, Bill Brewster. This episode is brought to you by Stream by Mosaic. You can find them at streamrg.com. That's streamrg.com. Stream is an expert interview transcript library that's become integral to my research process. I first discovered them about a year and a half ago. Since then, they have built out an incredibly robust transcript library. Stream by Mosaic provides over 300 expert interviews per week. 70% of their experts are found exclusively on Stream, and each interview goes through 3 layers of compliance screening. Recently, someone said Stream is table stakes for good fundamental analysis. I couldn't agree more. And I'm going to fork this read real quick to just comment on a debate that recently occurred in my life where we were talking about growth rates. And I really think that a qualitative, I don't think this is news, but I think a qualitative understanding of what is actually going on in the industry and why growth rates are defensible or not is an extremely important and definitively integral part of qualitative investments. And my 2 cents is that a interview transcript library can really pay off just based on the information that you can obtain in it. I understand that these are not cheap subscriptions, but I would just encourage people to remember that price is not value. This episode features Muji from hhhypergrowth.com. That's 3 H's, where he writes about tech. Muji has extensive technical knowledge about internet infrastructure, network security, and high-growth companies such as Snowflake. Each is unique. He shares his knowledge via a paid newsletter, which I sub to and I enjoy very much. I would not have been able to get through this conversation without Stream's library. To the extent I sound like I am a noob, I somewhat apologize, but also somewhat cop to being a noob to some of this. But Stream got me a lot of the background knowledge that I needed to be able to ask some of the questions, as did Muji's website. I hope you all enjoy this episode. It's a topic that I find absolutely fascinating. And as always, none of this is financial advice. All of the information contained in this program is for entertainment purposes only. Please consult your financial advisor before making investment decisions and do your own due diligence. Thrilled to be joined by Muji from Hypergrowth. I think I said that correctly. Writes the Hypergrowth blog with 3 H's. Referral to the show by Shomik. And I have really enjoyed subbing to your stuff and reading through the backlog. I have a ton left to go, Muji. You pen deep technical explanations of trends, and I have really enjoyed reading it. So thank you for doing it.
Yeah, thanks for having me on. Yes, I go rather deeply, war and peace length into some of these technical platforms. So it's not for the light of heart. So kudos for jumping in.
Yeah, it's been fun, man. The one I haven't been able to get to is the War and Peace on Snowflake. And everybody tells me that I have to, but I have my own little obsession with internet infrastructure and how it works and CDNs. And I don't fully understand what makes Cloudflare different from Fastly and both of them different from Akami. And so I'm working on getting competent in that language, and you write a lot about it. So that's where I've started.
Yes. Yeah. So I kind of wrote that What is Edge Networks piece well over a year ago now, kind of discussing the architecture that they've adopted. So yeah, happy to talk any level of depth in there.
Yeah. So I think what would be helpful, because not everybody knows what even an edge network is, but if you don't mind maybe taking a brief walk through memory lane of how we got here and why as a society we're using edge networks today, maybe try to help people piece together what the background, like the backbone of how they get their content looks. That might be a good place to start, and then we'll see where it goes.
Yeah, sure. So there's these services called the cloud that exist out there that I like to call, core centralized cloud.
I've heard about those. They're big these
Some
days.
call the hyperscalers, because what it allows you for is centralizing all your infrastructure using infrastructure as a service, IaaS capabilities, which is kind of the raw compute, memory, storage, networking that these clouds provide in a centralized place. So you can, create that at that raw level, core VMs, and really just move your infrastructure as is from your bare metal systems that you might have in on-premise centers into the cloud. Where CDNs came about is that once you have all of these centralized services, it really behooves you to cache that content around the globe in order to make it faster and more responsive to the end users, as well as greatly reducing the amount of hits that have to hit the what's called the origin server, the underlying web server or service that's delivering that content.
All right, even I'm going to make this even a little more basic just for people that really don't understand. If back in the day, maybe you had to send, the outbound signal from your device would have to travel over fiber. It would ping something miles and miles and miles and miles away, sometimes across the ocean, whatever, come back, takes forever. There's a delay. CDNs push the distance that the signal has to travel much closer to your device, right? And caching the information close to where you are means that the signal doesn't have to travel all the way back to, let's say, like Netflix is a good example. I'm sure it's probably on AWS, right? But it doesn't have to go all the way to AWS. It goes to sort of a middle or a point in between where you are and AWS is, and the information is cached, which means stored, so you can get the video much quicker than you otherwise could. Is that a fair characterization of what's going on?
That is. They serve content delivery networks serve as a middleman, a proxy for your content. And so as Netflix is streaming a video, that's it's a little lumpy with Netflix because that's a massive amount of content. So I like to use something like New York Times, publishes an article, much more smaller piece of content, but millions of readers are going to read that content or view that video. That's going to hit the underlying web server delivering that content over and over and over again, greatly increasing the amount of costs in core cloud. So if I have 1 million hits hitting my web server to deliver this article, that means I need a lot more resources in the cloud. I have to put a load balancer in front of it so that I can distribute that load across many servers that can deliver that content in order to even keep up with demand at that point. So even before we get to the latency, it's just about handling demand. I'm publishing something in one place. There's a lot of consumers, millions and millions of them that are hitting that content at once. That's going to create a massive spike in the load that the underlying infrastructure has to handle. And so caching moves that into a distributed architecture where they have what are known as points of presence, POPs or POPs, that are their edge servers distributed in data centers around the globe, so that I, a user in San Francisco, let's say, would be hitting content server in San Francisco that's caching that content instead of going all the way back to wherever New York Times has its data center, let's say New York. But expand that out further. A user in Hong Kong is trying to reach that same content at the same time. They can hit the cached content in Hong Kong instead of traversing the globe. And so absolutely it minimizes the number of network hops that has to occur, which greatly improves the latency of that and the round trip time, so that instead of it taking several seconds for me to circumvent the globe with my network request and then get content and circumvent the globe back with the response, it's much more instantaneous with having that locality of infrastructure. And so, Akamai was the stalwart here. It has hundreds of thousands of POPs distributed around the world that are very low power and really just ideally situated for serving content from a cache. If that content doesn't exist at the cache will go back and then make the request to the origin server and say, give me the content. It will then cache it for a certain amount of time from that location. And so instead of one web server or a host of web servers in one location serving up that New York Times content, you can have, in Akamai's case, hundreds of thousands of servers distributed around the globe serving up that content instead. And so, Akamai was the first mover here, but then Cloudflare and Fastly came about as kind of the upstarts to have a more programmable way of controlling your cache content. And that's really the architectures that they then created is what's spawned what I'm interested in this new paradigm called edge networks.
Why? So first of all, the other thing that is really cool, if you're not familiar with how all this works, but back in, before all this existed, the cloud and whatnot, like the New York Times would have to have their servers on premises, and they would have to build the capacity such that they could handle the highest potential peak, right? So things wouldn't go down. Now you can sort of share the infrastructure via the cloud. So it's just like much more efficient because everybody's not planning for their individual peaks and building out too much aggregate capacity. It's sort of shared throughout the system. Is that a fair characterization of what sort of meaningfully changed?
Yeah, there were a lot of transitions in the underlying technologies. Absolutely, the core of what you said is true, that you have to handle peak load. And so, for a live event that's being streamed, that's all in the moment, millions of users at once. For content from New York Times, it might have its ebbs and flows where you've got, it's some kind of topical piece for a local market that is an event coming up that weekend. It's going to get a lot of, traffic or, however the readership ebbs and flows any given moment. Maybe there's more nighttime traffic with, say, Netflix than daytime traffic. You always have to have the capacity to handle that real-time load. A couple of shifts occurred. One was the virtualization of things. So instead of bare metal servers hosting a web server, you can have VMs and have many web servers with a load balancer in front of them handling that load. And that is what initially started to even the load and usage of bare metal systems so that you could really maximize resources. From there, the migration to the cloud is enabling a lot of different directions. Certainly on the virtualization front, you can not only have VMs now in the cloud, but you can have containers that are a little more minified VMs and more specific to purpose and more programmable in particular. And then as you migrate to the cloud, then other shifts are occurring, such as the distributed nature of application architectures. So containers and microservices are starting to enable more distributed application architectures. Much less you can tie into platform as a service capabilities within these cloud vendors, such as database services, like you were mentioning, Snowflake can deliver, or MongoDB can deliver those services for you on that raw cloud infrastructure. And then serverless functions are the next wave of further dividing your application into these inner working pieces and having, in that case, erasing the concerns for the underlying infrastructure that it runs upon, which is the serverless movement. So a lot of kind of different waves of technology: virtualization, the cloud, containerism, distributed architectures with microservices, and now serverless functions. So you've got a wide range of ways you can architect an application that is housing your content. And now that further wave we were just discussing out, which is outside of your immediate zone of control, outside of your infrastructure, which is that CDN network can be hosting your content outside of your control, but delivering it more rapidly and reducing the amount of hits on your underlying infrastructure 1,000-fold or more by hosting that content on these remote servers instead of every request hitting your server.
And is it fair to say that the way that I'm gonna kind of call this all internet infrastructure, for lack of a better term, and please feel free to correct me if I'm wrong on that. But is it fair to say that the way that this is all developed has enabled the application on our phones or our computers to have less demand on the application, puts less demand on the device that we're using it on, and it's pushing sort of the demand out towards the CDNs or the back end infrastructure, and that has something to do with why there's such advances in what our devices can do. Is that fair to say, or did I mess that
Yes,
up?
you haven't. I guess that's skipping ahead a little bit into where these edge networks can go from here, in that they can basically provide compute directly away from your device in a very near location. And so that's a little bit the end of this story, or
Okay.
where we can lead into. It
Well,
is
let's
fair
go
to
to
call
where
it
we
all
should go in the
internet
story.
infrastructure.
I don't want to skip to the end because I like this stuff, and I want to help
Yeah,
people figure
exactly.
out
We should
why.
take a measured approach here
Yeah.
as we walk through these things. Yes, it's all internet infrastructure. I tend to call that raw IaaS portion of cloud services and platform as a service capabilities built on top of it, and SaaS services that are then built on top of that same raw infrastructure, such as MongoDB, Elastic Cloud, Confluent, Snowflake are building a service that you can tie into that's built upon raw cloud infrastructure across clouds. I consider all that cloud infrastructure. CDNs kind of exist apart from that. They're
Okay.
their own thing built outside of the core cloud. Everything else I just mentioned is in core cloud.
Hmm.
Where edge
Okay.
networks are going is outside of it.
So, do you mind explaining why there is a distinction there?
So what the CDNs have done, certain ones have started to build compute capabilities over those kind of dumb cache servers that they've been distributing around the globe. This was all built to handle content delivery. In Cloudflare's case, it was a little bit different in that they were trying to build a security product, and they have a core product that sits over websites in order to protect them. So they serve as a middleman proxy over any website, and content is one of the things they deliver. So Fastly was, kind of a competitor to Akamai, a direct competitor to Akamai, in that they wanted to build a more programmable content delivery network so that developers could use APIs to control the CDN content in order to refresh it as quickly as possible, and to basically manage what we'll call this distributed cloud that they've been building across these kind of smarter distributed cache systems. These
Okay.
edge servers that they're distributing around the globe. They're building programmability into it.
Okay. And Akamai, is it fair to say it's like a little bit dumber, for lack of a better term? Like you can't program it; it just kind of is there to cache information and get it to you quickly. Whereas Fastly, you can sort of customize it a little bit better. Is that a fair way to think about this?
Yes. So Akamai had as the leader in this, invented this technology as websites and mobile started taking off. That you had to cache this content elsewhere, especially in kind of this publish and subscribe model of the internet, which is, I'm publishing content, a video, a blog post somewhere, and people are then consuming it from there. CDNs really power that portion of the web. And they took the tactic of more is better. So
Hmm.
less powerful servers, but hundreds of thousands of them distributed around the globe to be as near as possible to the internet populace. The approach that Fastly and Cloudflare took is that they wanted smarter edge servers. So they have much fewer. Fastly has under 100. in
Hmm.
comparison to, probably 300,000 by Akamai. I haven't looked at them within the last year, but they had over 250,000 when I first investigated them. And so, they're building, it has more compute capabilities, it has more memory, and that allows them to then build in those kind of programmability into their cloud and basically interconnect all of those distributed servers and have it serve as one large distributed cloud. In Fastly's case, very devoted to content delivery. And in Cloudflare's case, starting to then pivot from there into other adjacencies.
Interesting. So how is the how do you have latency that is low enough to compete with Akamai if you're Fastly when you have so many few so many fewer is the word I'm thinking of, right? Like servers or CDNs rather. I'm sorry.
There's more to content delivery than speed. And so if you're going to solely focus on speed and have, a dumb cache delivering that's distributed everywhere, Akamai's your choice. But if you want more programmability into it and to tie your developers and better tie your application stack into that content delivery network, you're going to go with something that's more programmable.
Hmm.
And so you can have the best of both worlds in these new emerging content networks.
That's interesting. It sounds to me like the more programmable network should, in theory, be quite a bit more capital efficient, since you need a lot fewer access points, right? Or
Absolutely.
yeah,
Yes, because it's not just the servers that are hosting it, it's all the networking infrastructure, which is, I haven't really discussed yet, but that's kind of what's powered these smarter networks to appear is the rise of software defined networking. And so instead of having to maintain a stack of network appliances with your firewall, your routers, your switches, your load balancers, your DDoS protection, a host of any cybersecurity need, you used to have a separate appliance that all had to tie together in a giant rack. And now with software defined networking, you've basically taken that concept of virtual machines in application stacks and applied it to networking. You can have a core machine have all the networking ports, but use software to drive the behavior that it any particular application needs to have over that network. Can all be programmatic now instead of having to tie together these kind of legacy network boxes. And so that's really what has allowed these upstarts, let's say, to kind of create a better network. And in their case, a programmable network with many distribution points around the globe that they can now start taking advantage of in new ways.
interesting. Is it possible for someone like Akamai to pivot the way that they do things, or is the legacy sort of I guess tech stack for is it does it preclude that kind of a change within them, or is it, you know what I mean? Like, are
Oh, yeah,
are the entrants just attacking an incumbent that can't do much?
pretty much. Sorry, Akamai, but we've seen this story play out a number of times of a company that has a cash cow. In Akamai's case, it was, these arrangements they had with the stalwarts of the web to deliver their content. As companies are becoming more, I'd say, kind of next gen in terms of technology adoption, companies emerging like Shopify, let's say, that have a entirely programmable app stack, they want to tie into a more programmable network and distribution capabilities. And so you're going to find the future forward companies really starting to adopt with with these new content delivery networks, not Akamai. And so, they had the cash cow and were slow to pivot and they weren't even slow to pivot, or they weren't slow to see it. Let me put it that way. They were experimenting with edge networks, with serverless compute at their distribution points very early, from what I understand. The market wasn't ready. they shelved it and then were slow to pivot once it actually kind of became a thing.
Hmm.
And you've seen this with Splunk, who was very slow to adopt from licensing to recurring revenue for one move, as well as from on-prem to cloud. And you saw Palo Alto slow to kind of pivot from its firewall into other new modern cybersecurity techniques that are enabled by these more software-defined networking, programmable network capabilities. And so companies have to adapt on an ongoing basis, but because they didn't, it allowed some other solutions to emerge that have become their own thing.
Interesting. So, I'm just trying to make sure that people don't get lost here, and maybe I'm just talking to myself. So please pardon me, but a fully programmable app stack is something that you said. What is? I think you said that. I may be
Yes.
misrepeating. What exactly does that mean? And like, what was the old world like? In other words, what can we do now with this technology that couldn't be done before?
Yeah, I've written about this in my premium service actually quite a lot. It's the old method is what are called monolithic app stacks, which is that you're building kind of all your features into one giant application. You're having set releases of that application. It takes several months to kind of tie all these changes together, and you go through a formal QA process, and it all gets released at once every several months, if not every year. But as in the early days of the cloud, it was and on-prem, it's all about building all these capabilities into one giant system, and typically having not even using distributed systems. It's typically like one giant API built on one VM or one bare metal system. As I mentioned before, one of the application architecture trends that have emerged with the cloud and become a lot easier in the cloud is distributed application architectures. So that's kind of what I mean by modern app architectures, is the move towards away from monolithic applications and towards microservices and distributed application architectures, as well as serverless functions like AWS Lambda allows for, which is really breaking your application into your application might do 1,000 functions and you've combined them all into a monolith. You're breaking those 1,000 functions up into pockets of related activities in the case of microservices, or in the case of serverless functions, breaking them down to very specific functions that do one thing only. And that was very difficult in the days of old, I'll say, because it just magnified the number of applications you had to deploy, you had to test, you had to manage all of those things manually. Now there's tools emerging that are allowing better management over those things, better observability over them. So that's kind of what I mean by these, I guess I'd say, future forward tech companies, is that they've adopted microservices. They're a lot more nimble. Individual teams are responsible for specific portions of their application and they interwork together instead of one giant team trying to cobble together all these changes into one release cycle. Now it's all split. Not only do you have different ownership, you've got different release cycles, and it can be daily and even hourly with some of these companies with modern app, developer workflow tools. You can be releasing as you make changes. They can be being automatically tested and released in today's world.
That makes sense. I'm thinking of Microsoft, and I realize that this is software, but it's the difference between I have Windows 95, and then they're working on the next Windows forever, and then I get 98, right, to Office 365, where it's continual iteration, and I just get pushed out. Maybe there's like one thing that needs to be tweaked, but the whole operating system maybe doesn't get redone every single time, right? It's just like one piece. Is that a fair something that rhymes with what you're saying? Obviously, at a different level, right? This is software. You're talking about more infrastructure.
Yeah.
Yeah.
I mean, certainly it applies to kind of that monolithic approach. An operating system has to do 1,000 different operations. It's all combined into one giant whole and released on a set schedule. So exactly what you said, Microsoft had to collect all those things, test them together, and have a release cycle every several years in that case. And that's the way, licensed software has worked, that, you had to install an HR package. You would install it once and then you'd get annual updates, let's say, from there. Under SaaS, you could be being your SaaS service that handles HR software could be being updated hourly behind the scenes, and you have no idea. Why? Because behind the scenes, all those 1,000 things have now been broken up into separate pieces that all intertwine and intercommunicate with each other. That's kind of what's that distributed application architecture. It's entirely invisible to the user, but in turn, it's made it so much easier to manage software because every team is now responsible for their separate piece. They can develop it, build it, test it, deploy it at their own pace, as long as they maintain a contract with their company about how microservices have to intercommunicate and work together. A company needs to find a common platform for that. And then once that's in place, those pieces, I feel it becomes the better way to deploy application architectures.
Yeah, that makes sense to me. Something that I had heard you say in a previous interview, I think it was Brandon Belos, was that you're from the software world, and for a while you were hesitant to invest in software. Is that what you said? I'm not putting words in your mouth, right?
You're not. Yes, I was a very passive investor for the first several decades of investing. And as a software developer, I was very hesitant to invest in software companies because I knew what a house of cards they could be behind the scenes, how hard it is in that monolithic architecture to piece together all these changes, test what's called an integration test all the various changes together as a whole, not separately. You need to do both. You need to test every change you commit. But then once they all come together in a greater whole, you have to do an integration test over the entirety. Make sure one fix didn't break another, for instance. And so that has gotten, I felt like those early concerns I had in software in the early aughts, let's say, or the early teens of this century, have been eradicated because of these new application architectures. It's making the application so much more resilient. In particular, there's high availability concerns where you can now live deploy application changes, even in a complex, multi-container system, through a variety of deployment strategies and never have downtime, basically. And so there's better testing capabilities, there's better workflow tools. All of this is now automated in most modern software companies.
And I'd imagine that the customer of any given company in that environment is potentially less likely to get frustrated with the product that's coming out, right? Because if there's continuous improvement, like I used to hate Windows. Now it's actually pretty nice to use. And I think some of that's just specific, but I think some of it too is that the improvement is continuous, right? So I wonder if it's reduced. Often part of why I have stayed away from software as an investment is I've never really understood when I look at the valuation and I look at the current business. I'm morphing a little on this, so pardon any dumb thinking, but I've just never understood the duration argument, right? I've been like, man, this has to stick for so long in order for me to get paid back if I truly want to own the business in perpetuity. Now I think that the way that things are being developed, it's potentially a stickier relationship once you're in it. But I don't know. How do you feel about that? Is that flawed thinking?
Well, to step back just a little bit, I completely agree with where you're going in that these updates in today's app stacks are mostly entirely invisible to the end consumer. What the consumer sees is way better uptime, way more resilience of the software. It's just up all the time, pending major outages at AWS, like just last week. But these applications are more resilient than they used to be, and so they're more dependable. And so I tend to live in enterprise SaaS, which I see, to the latter part of your point there, as enterprise SaaS tools, and especially infrastructural tools, are becoming the underlying building blocks that other customers are building upon. And so, an operational tool, certainly, consumer, I tend to stay away from in general. It's just a lot more fickle of consumer sentiment. With enterprise, you get a lot of usage and a lot of users with a single sale. You're selling to a company, then 1,000 users have to use your software. That's a massive sale in one. So I tend to like that go to market a lot more. But I'm finding that these are becoming really deeply sticky services, especially infrastructural. If I'm using some kind of database service, such as Snowflake or MongoDB, and have built my stack on top of it, I'm not going to easily rip that out and replace it. And so it's kind of guaranteed amount of usage from that point going forward. And then hopefully as other companies succeed and grow, the person that, or the service that's providing these underlying infrastructural capabilities, is also succeeding and growing.
I like MongoDB as an example because so what MongoDB does is it's basically a database company, for lack of I maybe not saying it the right way, but DB makes me think I am. But it's like data entry, right? And you can be not quite as rigid as you might have had to been in Excel. It can be a little bit more free flowing, or it's easier to customize, right? But once you have your data entry into a program, what's the probability that you're going to recreate all your data entry, right? Like as a
Yeah, I mean,
business.
there's certainly competitors to MongoDB, and there's other document stores that you can morph your data into. So it's not like they're competitor free. It's just that once a software stack has been built upon it, it becomes an arduous process to you kind of, it's like lifting up your house, scraping out your basement, relaying a foundation, and putting your house back down. It absolutely can be done. It's just a major ordeal in order
Yeah,
to
well,
do it. It's not a quick change.
that's kind of what I meant. Why would you port your data over as long as you're getting some minimal viable output from the company you chose up front, right? I would think it
It
would be
is,
very
yeah.
competitive up front. And then once that sales process is over, the probability of switching is quite low, I would think.
Yeah, I mean, that's one of many, many things that I find attractive about software in general, and enterprise SaaS in particular, and especially enterprise infrastructural SaaS. It is that it's all forming building blocks that other companies are building upon, and doing it in a way that they have extremely high gross margins. There's very low capital costs. Really, it's just paying what I call the infrastructural tax, which is what they have to pay to the underlying cloud providers in order to provide this service on top of AWS and Azure and Google. Some of them live across all three, such as MongoDB, Elastic, and Confluent and Snowflake. And so, and then they provide an extremely sticky service. And then in a in those cases, a very vendor agnostic sort of way, in that if I'm an AWS shop and I have to set up all my infrastructure in AWS, well, now we've acquired a company that's all an Azure shop. But these tools are allowing kind of that cross cloud intercommunication that I also find very appealing in today's kind of stance.
Yeah, that makes a ton of sense because you wouldn't want to have, well, as an acquirer, the least amount of friction when you buy somebody is a good thing, right? So it would stink to really want to be able to purchase a target company and then all of a sudden they're an Azure shop and you're like, well, it's going to be terrible to migrate everything over. If I understand it correctly, if both of you use Snowflake, it doesn't really matter what the back end of Azure versus AWS is. You can integrate your data and share it, and it's just kind of seamless. Is that fair?
Yeah, I mean, this is what Oracle has proved over the past several decades, is that once you've locked in a customer into whatever your specific solution is, you can continue to kind of milk that. I think where they failed is maybe keeping up to date with, cloud trends as those got adopted. But, I'm finding a lot of these companies are now extremely nimble, and or can adapt very quickly. And especially having that distributed application architecture really allows for the underlying architecture is very modular. And so they can adapt very quickly with new solutions, especially like edge networks that are starting to appear.
It sounds like, as you're talking about this to me, like they're the the key, if you're thinking like me, I'm trying to learn about this stuff, right? So please pardon me if anything's really dumb, but it seems to me that you want to drill down to like the part of the stack that is not going to be that easy to displace, right? So if you think about it like, I don't know, a solar system, like find the sun's not going anywhere, but don't think that every star is going to be the sun, if that makes sense. I think I read
Yes,
that, which is
precisely.
why I thought that.
Precisely. Find the shining stars in here that have an extremely sticky service that aren't likely to go anywhere.
So how do you go about finding these stars? I'm curious what your research process kind of looks like and how you find new ideas and stuff like that.
So I'm a hypergrowth investor. I did have a detailed post called "What is Hypergrowth" that kind of goes through my investment process. There are some secular trends I'm mostly watching right now. Edge networks being one of them. Developer tooling, again, kind of those core services that companies are building into their application stacks. Like an example might be Twilio or Stripe, providing kind of communication or payment infrastructure into your application very easily. Okta for, identity management, that sort of thing. Cybersecurity with the trends towards zero trust and SASE networks, which is relying on experts to run your networking infrastructure and security instead of you running it yourself. Data and analytics is a massive trend right now. Everyone keeps saying data is the new oil at this point, and it's about making better use of it. We're seeing a lot of disruptive AI based companies starting to emerge in specific verticals, and so it's kind of all encompassing within these trends of where I tend to live. But then I look for hypergrowth companies, which in turn tells me a lot of things. Obviously, it tells me that they have a lot of current success, but behind the scenes also tells you that they have created a product successfully, are finding a lot of market fit, that customers are flocking to it and spending more, the land and expand motion. It is all visible to me in the hypergrowth, that they've had an initial success. It might be outside of their control, like the pandemic proved that a lot of companies saw an uptick in usage just with stay at home. So, I'm trying to find the durable secular trends in hypergrowth, adopting better security, adopting better networking, adopting better data tooling, adopting better dev tooling for application stacks. Those aren't going to go away. Those are not one-time trends. They're long-term trends over the next several years. So I tend to stay in those industries and then, try to find the better companies looking at the fundamentals in terms of the explosion of profitability that inevitably should occur. So, I do look at underlying margins. I want to see gross margin going up, which shows that they're making better use of the underlying platform that they're built upon, the underlying cloud service or IaaS infrastructure. And then, better operating margins that the company itself, its sales force and R&D is able to do more and more with less. But really where I tend to then live on top of all that's kind of all in the financials and the KPIs that the company reports. I then look for how are these platforms built? What are they built upon? What are the adjacencies I can see them entering? What are their product releases telling me? What are their customer conferences telling me? What is management telling me in earnings calls in terms of where the product is morphing? How does that then turn into adjacent markets that they can enter and increasing TAM? And so, it's finding solid companies that are doing extremely well now and that I expect to continue to do extremely well in the future.
Okay, so if I can sort of like say that back to you, it sounds to me that you're top of top of the funnel idea generation is looking at the financials for hypergrowth, which you define as north of 40%, right?
Yeah, it varies, but it's about 50% at this point
Okay.
is the minimum.
All right. And then,
Depends
and
on
then,
the quality of companies I'm finding where that line is drawn.
okay.
But
So
generally, companies over revenue growth of over 50%, and in turn ARR growth over 50%, and then high gross margins for over 70% and growing, ever increasing towards the positive operational and cash flow margins. And then if they are cash flow positive, fantastic. And an NRR, net retention rate, over 120%, which tells me that the companies that are currently use the product last year are spending 20% more this year. So usage is increasing. And so that, with the customer growth metrics, show me the land and expand motion within these companies. I want to see lots of lands, new customers entering the ecosystem and spending more and more over time.
that makes sense to me. And then, so will you, do you tend to try to, let's say you find this company, right? Snowflake, for lack of a better example. Will you exit then once it exits the hypergrowth stage, or are you okay owning it forever?
I don't own forever. I am okay with exiting or keeping it after it exits hypergrowth. I actually held Okta quite a long time because it was such a well-positioned company in so many different trends at once, until I started seeing operational issues or product issues where I don't feel that they're not growing to the best of their potential. And so I, ultimately will exit when I see faults. But certain companies do have a lot of long tail, so I tend to hold them quite a while.
Why are you willing to exit when you see faults?
I run a very concentrated portfolio, under 10, sometimes as low as 6, but typically 8 to 10. And it's that I have better ideas. And so companies will fall out of my top 10, and I'll just move on.
It's interesting. It's like I'm thinking of your portfolio like a baseball team, and it's like you've got a bunch of 5 tool players, and then the valuations that you pay make me a little queasy. I don't know everything that you do, but I do know that where you play, and optically that makes me queasy. But I think that your strategy makes sense in that pond, because you're not really, if I understand you correctly, you're probably out before there's like a real problem and there's multiple compression, and you're trading for another young player that's a 5 tool player and refilling the baseball team.
Yeah, I'm not always out before drastic events. There's always surprises from companies that report issues. Like, I was in a company called Zscaler that in end of 2019 was showing a lot of issues in their sales, and the customer growth was drastically falling, which to me affects the land and expand. You can't have all the success and expand if you're not landing the customers in the first place. And so, I exited at that time. So, the faults vary, whether it's newly spotted competition, the trend isn't as durable as I thought it was, or the company is showing faults in management or execution. It tends to be the primary reasons, not so much price driven.
No, that makes sense to me. You're looking at the fundamental outcomes of the company, and you're not looking at stocks to as your
Yeah.
stock prices. It's not like a
Yeah,
technical
it's all about the
approach.
fundamentals, but it's about riding companies that are executing well and I expect to execute well in the future,
Yeah.
and letting them do the work. And then constantly watching them to make sure they do the work. Let's be clear.
Yeah.
Watching them continuously, but but recognizing companies that have some kind of special sauce for executing well in the past, and I expect to execute well in the future.
So what
And
is
so
that?
sometimes I'm late to the game. I because I'm so stringent in my requirements that a lot of companies I could have entered earlier, but they weren't showing, let's say, operational leverage that I like to see. I weren't seeing the underlying margins kind of constantly trending positive. And I wait for them to, write and show better execution, and then we'll join in.
So, what does this look like in between quarters? Are you doing I know you're doing stuff in between quarters, but I'm just trying to figure out, like, are you doing scuttlebutt? Are you I mean, you've got a big following on Twitter. I've got to imagine that you've got a bunch of tech friends. Are you pinging people, asking them, what are you hearing on the ground, or how are you using this product? Or is it mostly that you're assessing the competitive landscape and then watching for the financials and listening to what management says? Or is it a combo? I'm just kind of curious.
Yes, so constantly watching what management is saying through earnings is important, much less keeping track of the fundamentals. But I constantly like to see what they're talking about in terms of product line and adjacencies that are possible. But really, it's not talking so much to tech friends. Most of my research is all me. It's and then I started the blog and now have a premium service on top of it and the Twitter. But it's all kind of revolving around these companies. I tend to watch not only the earnings, but other investment conferences can sometimes have interesting tidbits emerge from, the CFO is talking to, at some related industry conference. But it's the product announcements that is probably where I tend to live most. I like to
Hmm.
watch the product cadence, how quickly they introduce new products, how they go through beta and then into final release. I like to look at their customer conferences, which provide a surprising amount of insight for investors. And companies are learning this and starting to attach investor days to their customer conferences,
Hmm.
like Datadog's Dash conference that just occurred in October. They had an associated investor day to kind of talk about, hey, first off, customer conference, we released a huge host of new products. It's their annual event where they dump several new products, and there were 10 odd new ones on the horizon, either being released or in beta at the moment. But then they had an investor day to kind of weave through it and talk about how this all combines into the greater story of where the company is going. I really like that stance by companies. It makes them so much more transparent. And that's where I like to live, not just on the fundamentals and the numbers. And I don't tend to go over those extensively in my service. I'm talking more about the product lines and how we can read the tea leaves and look through the lines in the product releases to see where companies are going next.
Yeah, that makes sense to me. I think I've noticed, and I may be incorrect when I say this, but it seems as though your more recent posts have been more about like zero trust and security generally. Is there a reason, if that is a correct statement, is there a reason that has sort of captured you recently, or
Oh,
is
that's
it
not
just a
recent at
function?
all.
Okay.
I first wrote on in October 2019. I wrote a series called Flavors of Security. It was pretty, you could see zero trust approaching from a mile away. There had to be a better way once we no longer have a perimeter, which was, a company would, have a headquarters, create telco lines that interconnected all the branch locations or retail locations or whatever various spots their employees might be working in, factories, warehouses, distribution centers, whatever, all, interconnected through, telco leased lines. You'd have to draw a perimeter around that company. So you could have a moat and a firewall could control the entry and exit into the company network. But once you were on the company network, everything was trusted. Back kind of in the late teens, but really for me, culminating in October of 2019, you could really start, or 2019 in general, you could really see it starting to be adopted. So you can talk about it for years and years. IoT, we've been talking about for years and years, and has that really truly exploded? Not yet. We can talk about that if we circle back to edge networks, but it's recognizing that security is at the forefront of management and even board of directors' minds at this point. And you can see it in the number of breaches that we have monthly and even weekly into these systems that are stealing data, releasing it to the public, holding these companies for ransom is been the huge trend over the past few years. And so it was just kind of recognizing the need pretty early there. But yes, I've continued to talk about it quite extensively over the past few years.
Yeah, I didn't know if there was a reason that it seems very prevalent, right? Versus maybe I see a lot of other people write about SaaS and things like that, and it seems like you tend to be from I'm a sub for like 2 weeks, so if I say this incorrectly, I apologize, but I do really like reading what you write. It seems like you have more of a security focus than some of the other people that I've followed. So I just didn't know if there was a particular reason for that.
I wouldn't say I have a security focus. I've been for decades in software. I have been a database developer, lead application architect for years and years and years, even as a hired gun consultant for most of that time. And so I've just been around app stacks as the cloud became adopted, as these new modern application architectures have started to emerge, as data services have started to emerge, and machine learning and AI have started to take hold, big data. So I've kind of watched it all firsthand. And so I kind of have an understanding over all of that, what it is developers look for, what kind of security tools companies need in their infrastructure, how infrastructure works, how application stacks are installed upon this infrastructure, and then how application architectures are built on those application stacks. I've kind of got a knowledge over all of those directions. And so all of those kind of swirl around. Security is but one focus, it's not a primary one. So
Okay.
it's anywhere into data, infrastructure, application architectures, dev tooling, which is the underlying workflow of how you build and deploy your applications, and or the SaaS services that you embed within your applications, and now data and analytics and machine learning and AI is kind of also starting to consume me. So all of the above, please.
Yeah, no, that makes sense to me. You sent me down a zero trust rabbit hole. I liked it a lot. Do you want to explain to people what zero trust is and why it's so important relative to sort of the old way of doing things?
Yeah, sorry, I kind of started on that route. So as headquarters enterprise networks used to be very tightly controlled in that it was all under the enterprise's control, I should say. You would have your headquarters attached to your remote locations, attached to your branch locations, attached to your retail or warehouse or other facilities that you've got as a company. You would draw a network perimeter around all of it and keep that moat with a firewall. With the emergence of cloud services, you don't own that infrastructure. You can control it. Some of them are programmable via API, but it's not within the boundary of your enterprise network. And so there really is no perimeter at this point. There is, people call it a software-defined perimeter now with the emergence of software-defined networking that we were talking about earlier. And so you need better tooling as an enterprise to secure your assets now that they can be on-prem. It can be users that are on-premise and networks and systems that are in your data center. It's remote users, which we just saw completely explode with the pandemic last year. So now users can be anywhere, but from your on-premise data centers, you're starting to move into cloud infrastructure and then reliance on SaaS services such as Microsoft Teams or Zoom for intercommunication, Office 365 for your email. You've got HR packages, you've got financial packages, travel reimbursement packages, whatever else you need to run your enterprise. You can't draw a perimeter around cloud infrastructure, much less those SaaS services you're using. Zero trust is the emergence of networking and security in one. You combine them all together in order to have a service provide that for you. So you're kind of relying on the experts to handle your network traffic in a secure way across all these separate environments.
Hmm. Is your this may be stupid. So again, I apologize, but is your the way that I log into your site, is that a zero trust? No? Okay, it's stupid.
No,
I can edit
it's
that.
there's no stupid questions.
There are plenty.
It's no. I'm used to talking to generalists, so I always love kind of breaking this down and making it explainable. Is kind of my forte. And that's what I did as a lead developer. I constantly boiled down really complex architectures of distributed networks and distributed applications and servers in an understandable way for management's consumption and then for my clients' consumption. So I'm used to boiling things down. And Zero Trust is a way, it started as a way to manage how your users talk to applications. And so the infancy of Zero Trust was that I have all these applications I run internally. They may be on premise, they may be in the cloud. Zero Trust provided a common interface that users can all go through. And instead of being a firewall into a network that the user can then move around in, which is what a VPN does. You log into your company's VPN in order to get into the trusted network of your company. And then you can access the HR package, the database, the development stack, etc. That's a trusted network. We're moving away from a trusted network to everything being untrusted. Now the user has to establish who they are through a variety of techniques, either coming from an identity management system, an SSO like Okta, having hardware keys. There's lots of ways now to prove you are who you are. I'm this user. I could even be tracked down to that. I'm on this device, a laptop or mobile device. I'm request a service from this kind of gateway, and I ask for access to the service. Let's say I need to access the HR package. It establishes who I am and makes an ephemeral network connection to the HR package. It doesn't directly connect me to it. It serves as a proxy between those two things so that it can completely control security in real time over that connection. Once that is severed, I no longer have access to the underlying HR package or anything else within the enterprise. So this is a one-off ephemeral network connection, is handled by these Zero Trust systems for every user request into an application. And so that's expanded further from there into what's called SASE networks, which are Zero Trust plus networking. Now I've got all these interconnected spots. Let's say I have a headquarters and I have 500 retail locations across the US that all have a point of sale system and employee tracking systems and inventory tracking systems and whatever else exists on these within a specific retail location. I want to interconnect a network between those things. I can now use a Zero Trust method where I can have a common networking backbone hosted in the cloud that handles that for me. All of those retail locations make a specific connection to this centralized service, kind of a centralized control plane, and then can all intercommunicate from there. And so you've layered that kind of networking and then put Zero Trust over it, which is that I'm a user and I still have to establish who I am before I can talk to any service across that network.
I want to defend myself real quick, because if I want to log into your website, I have to have you send me a code each and every time. So that's kind of what I was thinking, but I recognize.
Yeah. It's related. It's establishing who you are through one technique. Email is not a very secure.
Yeah. Well, that's technique. What I kind of thought. I was like,
so you're not going to use that for, logging into your financial system.
Right.
And so, or, let's say you're Twitter employees and you have to log into the control plane to, delete someone's tweet or something. You've got to go through a sequence of events in order to get into those internal systems now. Zero Trust is helping solve that.
Yeah. All right. That's cool. Can we move I'm sorry, what?
I was going to say this all is actually circling back to edge networks, which we left sitting there as I have started to explore the app stacks.
Well, where do you want to go with this? Let's go somewhere.
That's what's appealing to me, is that what we were talking about at the beginning, is circling back now into the rest of the story, which is that these companies have built, the CDN companies have built a distributed programmable network spanning the globe, and then have computers that are serving as those cache servers, smart caches, in whatever select cities, in order to reach as much of the internet populace as possible. And so that was great for application stacks and delivering content. It was crucial and really greatly reduced companies' costs with hosting in the cloud. You're only hitting your server, a thousandth of the time if you have a cache server over it. But not only that, Cloudflare in particular provided other things like application reliability, application performance, in that they started kind of building their own private internet over that programmable network. And so that they could start routing traffic around problematic areas of the internet. If they see like a ISP has gone down in Atlanta, they can route around it, for instance. And so, they served as a layer over your application stack. And what they and Fastly started to do, and why both companies were really in the limelight in 2020, is the market got a lot more clear about what edge networks are, which is they could start building compute capabilities like a core cloud provides centrally at those edge servers. So, core cloud, I'm going to start infrastructure. And when you start with a company like AWS, you have to pick the location, the centralized cloud location that you want to put your information all in. So you'll pick one region.
Like
It'll
Texas
be US East
or
1.
something.
Exactly.
Yeah.
It might East Coast, West Coast, somewhere in the middle in terms of the United States. You'll pick one location, put all your resources there. And maybe you'll spread out from there into other regions or availability zones just for high availability if one goes down, as we just mentioned. What edge networks are starting to allow is building compute capabilities for serverless functions that are distributed to all POPs at once. And so now I can have my application, I can deploy it instead of into one location, US West, East, and AWS. I can say in Cloudflare, if I'm using workers, I can deploy it and it will deploy to all 250 locations at once. Meaning I have an app that now is not situated in one place. I have an app that is spanning the globe in one deployment. So when you're dealing with consumer apps, that's greatly putting the kind of back end of an application that might be on your mobile device within a single hop or two. So incredibly low latency of most of the internet using globe. And so it's becoming a new infrastructural play where they've got the programmable network that interconnects all these spots spanning the globe. And then they're creating a developer ecosystem over this compute capability so that customers can deploy applications to control the flow of traffic across that programmable network. So it's all kind of circling back to where we just landed, in that zero trust and security is one of the use cases of a programmable network, in that you can control where traffic flows, so you can control the security of that traffic. And so I'm finding that edge networks provide a ideal architecture for zero trust, regardless of where the user is. Me, the enterprise user, used to be in, headquarters in Chicago. Now it's dispersed around the globe, logging into the enterprise network. How about using that distributed server architecture with a programmable network in order to handle the networking and security traffic as I traverse the enterprise network and use the SaaS services that the enterprise signs up for?
And they're able to do all this with far fewer actual locations than someone like Akami it was or is. I mean, Akami can't do it. I understand that's probably the answer, but how are they able to do it in such an efficient manner? Is it because they're software defined networks? Is that like the core?
Bingo.
Technology breakthrough?
Software defined networks. That's the answer. It's because they can basically create this globe spanning cloud because it's all software driven under the hood. They control the networking, they control all of the infrastructure via software, and they have kind of leveraged that architecture that they built for CDN, for content delivery, in order to help distribute the application, across the globe.
That is some wild shit, man.
And now, I mean, it's not just that; it's a mesh. It's not just 250 separate application development points. They can talk to each other. You can route traffic between them. That's kind of where the security features have also emerged in these platforms. Is that a user, if I'm anywhere near Chicago and I need to enter the network, I log in through the POP in Chicago. I establish a secure connection with that POP. Or if I'm in Hong Kong, I'm talking to the Hong Kong one. Or if I'm in Indonesia, I'm talking to the Jakarta one. Once you've established your identity and your zero trust kind of security credentials with that network, now it's Cloudflare, in that case, is in charge of the global network from there. They can handle all the security within their walls of their private network as it spans the globe, instead of you traversing the public internet. So there's really now kind of a division between private and public internet, and as well as that they're creating this kind of globe spanning cloud capability.
Huh. Okay, so if they're able to control, so if Cloudflare is able to do that for you, that seems to me like what they would market is they can control the level of security within, it's almost like a private internet that they've created. Is that, or is that really dumb to say?
No, that's exactly correct.
Huh.
That Cloudflare and then Zscaler is another company that's architected around this edge network capability where they've got these POPs distributed around the globe. Those POPs have become basically gateways into their network. It becomes the entry and exit point for their network. And so just to walk through a typical user request, I'm a user currently situated in North Carolina. I establish a connection to the nearest POP, which might be Atlanta. From there, I'm entirely within Cloudflare or Zscaler's network until I get close to where the application is hosted. It will then exit the POP and enter the cloud service of where that SaaS service is located, let's say Microsoft Office. I then securely created an entire network connection between me and a SaaS service at that point, and then back for the response. And so these networks are starting to interconnect with the clouds to even remove the kind of exposure to the public internet once you have to exit their network and talk to whatever the service is. Or they have tunneling capabilities that I can kind of create a secure tunnel between an on-premise data center and their edge cloud.
And are these, they couldn't possibly be laying their own fiber. So they've got to have some sort of wholesale agreement. Is that a potential security breach or no?
Oh, for sure. Yes, they have infrastructure they have to rely upon. They're not laying their own cable. They're renting fiber. They are utilizing data centers like Equinix to kind of create these data center and locations around the globe for their edge servers. So those are the gateways, but they have to rely on other people's networking and infrastructure in order to build that out. But this goes back to kind of the core of these companies being so security focused and having a software defined network, is that they can guarantee that their stuff is entirely encrypted and not visible by the underlying infrastructure. Actually touches on another infrastructural play I've been seeing lately, is as companies are starting to rely on the cloud more, they want to start encrypting their information more just to not have that exposure you're talking about. You use AWS, AWS can see your stuff unless you encrypt it at rest and in transit. So you're starting to see security plays around that as well.
And when, so if I am using Fastly or Cloudflare to get my content close to my customers, I also have an agreement with AWS, right? And AWS is going to share my my core information with Fastly and Cloudflare, or can I completely cut AWS? I wouldn't cut AWS out, right? Or
Well,
Azure or
there's
GCP.
there's where that's a very interesting question about where this all goes going forward.
Yeah, that is where I'm trying to
For
go with
now,
this.
what you say is true, that you're always going to have your core infrastructure somewhere. The CDN networks were a layer over that, but not eliminating the underlying origin servers that they talk to. I'd say the same is true for edge networks, but ultimately, as edge networks become more utilized going forward, they should absolutely eliminate certain use cases of why you would host in core cloud. So there's always going to be the need for like centralization of data. You want to run machine learning with a high amount of memory and compute, and over a vast, history of all your data over several years, let's say. That's always going to happen in core cloud. But anything dealing with network transmission is highly programmable now in these new clouds. And so you're starting to see services emerge on edge networks where, again, it gets back to that middleman nature of CDNs. The same architecture is in place for edge networks. It serves as a middleman. You can have now a programmable middleman. You can have these applications controlling how traffic flows across the globe. An easy use case is just controlling, I want it to go to this data center versus this data center. But you can start stitching responses together. They've mentioned like last mile ad insertion. Instead of you having a request that goes all the way to the cloud and things get assembled from various services there, it can be doing the assembling at the edge now. And so it's just starting to open up a whole lot of new use cases that I think will take business from core cloud.
So my gut, like visceral reaction when this conversation started was core cloud is still got most of the bargaining power over the long term. This recent part of my conversation has me thinking that I have a lower confidence interval now than I used to in that statement. Does a company, and I'm not asking to do this Snowflake deep dive, I don't even know that my brain can handle it right now, but like Snowflake is able to be used across cloud providers. If it is also able to be used among edge network providers, does that sort of commoditize or level some of the playing field? Or am I not thinking about that correctly?
Well, that was the one of the use cases I just mentioned, where
Okay. I just want to make
Snowflake is
sure
all about
because
centralization of data. And so, to use AI and machine learning properly, you need more and more data to train it on. Now, some of that is going to move to edge for sure, where you might have real-time analytics running over the data. This is where a company like Confluent, has a lot of power as a data messaging platform that kind of lives across clouds. But that's what's going to be interesting from here, is seeing what the use cases are that split. But I don't see Snowflake moving into the cloud, or sorry, into the edge. It does live right now above the three major clouds in the US, and you can seamlessly, as a turnkey service, transfer data across those clouds so that you can have users in Azure and users in AWS, or users in two different AWS regions, for instance, all operating on the same set of data. And same with MongoDB. They're all starting to become distributed data stores across clouds. And that's a unique differentiator than comparing them to the same related services like data warehousing or document stores in that the core clouds provide themselves as a service. Where edge is going to come into play is the transmission side, I feel like. So you still have to get the data from somewhere, and you still have to transfer it to that centralized location. And then from any insights that you extract in that centralized location might need to be distributed outward from there. And this is kind of getting into how the nature of what is the internet is changing for me, which is that the internet thus far, in what crypto people are going to call Web 2, is that I'm producing content, I'm centralizing that content somewhere and distributing it outward. the pub sub
Mm-hmm.
model. I'm publishing something, a YouTube video that gets placed in a centralized server somewhere and distributed out to millions of people. What's changing now with the rise of IoT, with the rise of 5G really enabling much faster speeds at the last mile, is that data collection is going to come from all the endpoints that exist out in the globe, all the
Mm-hmm.
IoT devices, all the OT devices, all of the user devices, the connected cars, the connected buildings, the connected cities are all creating a vast amount of data that's now flowing inward. That's the paradigm shift that I'm seeing emerge that I think edge networks are going to have an extreme amount of power for, is that they are the programmable network in between all of these things. They're the kind of the interconnective glue and can help transmit data wherever it's created to wherever it needs to go, regardless of if I'm that pub sub model and all data is going outward, or if I'm collecting data from remote locations and it's all coming inward.
Hmm. So is this sort of circling back to a comment that you said, like IoT hasn't really taken off yet, but we can come back to that, or have we come back to that comment? And is this sort of the technological advancement that may enable IoT to take off like people said it would?
Yes. So certainly the one of the big unlockings for IoT I feel like is 5G. That you've got better remote networks, that IoT doesn't have to be wired. You know, you had to connect all these sensors into a local network in order to make use from them, and there's just a lot of friction in adopting, you know, devices or sensors across your business. And but it's so helpful because those devices give you observability into all the things within your business. Let's say a factory or a smart tractor, so that you can monitor, how things are happening on your agricultural business, or whatever. And so it's 5G is the first unlock for sure, and that's still just emerging. Edge networks, I feel like, are the next unlock, which is now that we have all this capability in the last mile, we can start leveraging it in better ways by having compute capabilities and edge cloud, where we can be performing actions where the data is being collected instead of in a centralized cloud location.
This makes sense to me. So 5G enables these devices to communicate with the edge network in a low latency, like very, very fast, very seamless communication. And then the edge networks enables the company or whoever's trying to perform analytics on it or whatever they're trying to accomplish. That's sort of the new technological advancement that allows sort of the vision to come to fruition. Did I just say something that makes sense?
Yes, those two things combined. So this is all on the transmission side. Yes, 5G is going to, explode the amount of bandwidth capability and the number of concurrent connections that can occur from a single tower. And so the amount of data is going to explode, and you can start making better use of that data in edge compute. Absolutely.
Hmm.
But there's another use case I see emerge from this combination, which is you've got a lot of dumb devices. I could be reading temperature pressures, air humidity, if I'm monitoring something environmental from dumb devices. You could be having smart compute at the edge, a single network hop away. And so that low latency really starts to come into play again. It's not the most important feature, but you can basically start enabling things like AI and make dumb devices smarter through this combination. That I have the fast networking that gets this data into an edge network. First off, the 5G gets it to the tower. The tower has a hop to whatever the ISP is. From there, it's a hop to the edge network. So instead of going through multiple hops in order to get to a core cloud to make a decision, the decision can be being made very locationally adjacent to the dumb devices collecting that data, and or can be collecting data from many devices, making a decision and then giving its results back to all the devices. So I do see a pretty positive future trend in where all these things are swirling.
Hmm. That's super interesting, man. I I want to keep going, but I'm tired because stretches my brain so much. It's funny. I put out a tweet the other day, and it was a little while ago, but I said, for the longest time, I was so stupid that I would look at some valuations and I wouldn't even get curious about some of this stuff, right? And like, the amount that cost me in, curiosity, potential career, decisions that could have been different. Like, I just hope that no one else does that, because this stuff's so fascinating for me. And even if I can't predict where it goes like you do or whatever, like, it's just such a fun conversation to have, but it like tires me out because it requires a lot of hard thinking the whole time. For me, it probably comes second nature to you.
It's well, so I'm a combination of technologist, software developer for decades, and a hypergrowth investor. But there's one word in there that I would disagree with, which is predict. I'm not predicting anything. This is the key to my investment thesis, is that I wait for companies to prove to me that they can execute. And then I can see where they can go from there. And that's where we start exploring these interesting technology combinations. But I'm already starting with the basis where these companies are excelling at what they do now. And then I see where they can go going forward.
And you may have said it before, but in case you did not, the other thing that I know that you like to see is you like to see that they're releasing other products that are demonstrating people using them, right?
Yes, absolutely. So, I mean, certainly I have the financial metrics I look for, and hypergrowth, signs of operating leverage, a fantastic gross margin, the land and expand you can see in customer cohorts and NRR. But absolutely, this is why I like to watch the product cadence, as I call it, the cycle of how they release products, how they're entering adjacent markets. I like to see a harmony between sales and product. And that's proven to me in product cycles and NRR, is that, I like to see companies that are kind of ever expanding the menu of options of what it is they provide and then selling it to existing users. But that in turn is what kind of proves to me that they can start entering these adjacent fields that can kind of spot that they're starting to move towards.
That
If
makes
they have
sense.
enough success at what they do now, they continue to iterate on product releases, and sales can sell it. And then, that's, as I like to say, it kind of creates the hurricane of growth, which to me is all about scale. I can see signs that the company can continue to scale its sales, continue to scale its operations, its profitability, its product line, and then adjacent markets.
All right. So the one thing I do want to touch on, since it is an investment program, Snowflake. Let's not get into the deep dive of it. And I think everybody, if I haven't plugged your blog enough, I think people should sub and they can read what you've written on Snowflake because it's very extensive. But when you look at these,
That's the half of it. I've talked about them about 4 more times this past
yeah. Well,
projects I have.
I really I encourage people, especially if you're a generalist like me and you're interested in this stuff. I find Muji to be a very good resource. So, but when you look at something that has $100 billion valuation, how does that, or I don't know what it is today, is it 80 or whatever? Like, at what point does valuation come into your process, and do you ever look at something on a market cap basis and say, that's a little too big, right? Of either a multiple or a gross valuation.
Yeah, I can't say I ignore it. It's just not a factor in my conviction, I guess I should say. Now, Snowflake is a little bit of a special case in that I was mad at them because I saw them coming from a mile away, and I really wish they would have gone public sooner. These companies today are now finding so many funding rounds that they can stay private longer, and someone else is gaining the benefit of that, not me as a public market investor. And so I had expectations that at IPO that they would explode. And so when you have a company that everyone and their mother is all watching, obviously the interest level is too high, and I stayed away at IPO. It was just too much. So I guess I do have my limits. It just doesn't generally enter the equation so much as I evaluate new companies, especially ones growing over 100%. And I think that they can sustain that really has a way of making the valuation metric not matter over time. And so, there's a lot of compression can occur when a company is growing 100%. And so, somewhere in between there is where I live as an investor. And so it doesn't always enter the equation. It's obviously a frothy market and got taken to the woodshed here a little bit over the past few months, but that occurs, especially when it occurs so in tandem across all of tech and kind of all of hypergrowth. It's just, market moves. It's not indicative of any one company, and I'm hyper focused on individual companies and their performance.
Yeah,
And so, if this company is $60 billion of market cap, the question I ask myself is, could it be 100 billion? Could it grow from here? And if I see those adjacent markets, then yes, especially if they're growing 70, 80, 90% year over year and are doing so in a sustained way and showing signs of extreme profitability that they can, once they, land and expand starts to wane, they can have those levers to turn up the profitability strongly, or even better, those levers have already been achieved just through simple scale of their business. It's ultimately a very successful business at the end of the day.
Do you think in some of these companies, like, is there a risk that as they mature, their best people kind of leave and go to the next startup, or have they already hit such escape velocity that it doesn't really matter? That's something that I kind of wonder about. Like, are these companies able to run at steady state and keep their culture?
Well, that gets back to my house of cards comment a little bit in that, as these companies are scaling up so much, let's say Monday.com just was growing 94% and just put in 97%. It's accelerating. What does that do to company culture when you have to onboard 100% new employees in a year, let's say, and especially when things may have been on premise and are now entirely remote? Certainly culture might be affected. It's also becoming the era of where developers are a currency. It's developers are kind of in control of their destiny and can pick the, kind of career path that they want or industry that they want to be in. Every company is a software company at this point, just to some degree. Either it's stitching together the existing SaaS tools that they've got with their existing legacy tools at a bare minimum, or they're creating software on their own that they have applications in an app economy or API economy sort of direction. So, I don't see these trends ending, and developers are becoming harder and harder to get. So I think there's going to be more use of these SaaS platforms, more use of the companies that have proven that they've become an expert in security, in data, in analytics, and relying on their expertise more instead of hiring staff to do it for you. So, I'm still incredibly bullish on software in general because developers are hard to come by. And yeah, you do see that as these companies grow. This is why I'm constantly looking for signs of operational faults and issues with their product release cycle and customer growth. Is I want to monitor that this massive swelling of successful execution isn't causing any issues in my long-term thesis.
Yeah, that makes sense to me.
Important to watch.
That's what I would watch too. So that makes sense. Well, man, I mean, I thank you for joining the program and sharing your knowledge. I will remain a sub, and just thanks in general for writing what you write. I'm going to pop into more of your Twitter spaces because I really enjoy listening to you talk. I like how you come from like a tech focused. There's so much discussion that I think I think there's a lot of flat discussion out there, and I find what you write to be very high signal. So to the extent I'm a good judge on that, thank you.
So I'll take the compliment. I appreciate that. Thank you. It's yeah. Twitter's been fun. I've been around kind of bulletin boards and investor forums for decades now, and it's always been high noise to signal through a lot of it. Everybody clearly pitches their own book and hypes up whatever they own, and so you've always had to kind of separate that. But yeah, I feel like I've got a little bit of a unique perspective here between the technology and the investment focus, and so I'm glad I can help folks. And so yeah, I created that. I've been writing for years, but created that blog when kind of things went haywire in the pandemic, and then decided to leave development behind earlier this year and start a premium service. So thank you to all the folks who pay me to opine about these things. And it's been super fun thus far.
All right, cool. Well, I look forward to future conversations, and thanks again.
Great. Thanks for having me on.